Hi, I'm Toby from AWS. Welcome to This Is My Code from reInvent. I'm joined today by Jason from SparkPost. Hi, Jason.
Hello.
Welcome.
Thank you. It's great to be here.
Great. So we've got some code here up on the board. Do you want to tell me a bit about the problem you were trying to solve when you wrote this?
Sure. So we, at SparkPost, deliver a lot of emails for our customers. We provide an outbound email service, and part of that is delivering event data for those emails to our customers, both through reporting and webhooks. So as we deliver emails, as people open and click on them, we want to have on those open and click events that go out to customers data about the initial send that they had. So in order to do that, we basically store a cache of the events in Redis, and then as time moves on, we move that to S3 because emails most of the time are open very quickly, but sometimes people will go back and open emails that are much older, and we still want to have that enrichment data on the old events. So enabling both lookups on new events fast and cheaply, and then the longer tail of old events in S3, we found a great harmony there between these two systems. So what happens is, as data flows through the ETL, it gets written to Redis, and it gets written to Redis in real time, basically. And then we later batch that data and write it to S3. So the first part of this is getting that data out of Redis. So this getMinute function here is something is a custom function that will look at all the keys in Redis for a minute. And the way we store this data in Redis is took a little bit of work to get to because we store it in hash sets. And the hash sets initially were the entire minute's worth of data. And what we found is having that much data in one key in Redis and operating on it very frequently caused the Redis CPU to spike to almost 100% per instance. So what happened is we changed it to be 256 keys for 1 minute and just append a smoothing hex bit in there to get that to smooth out.
Okay.
So
just to cut in for a minute, so the function is running in Lambda, it's Node, and the purpose is to archive data from Redis to S3.
Correct, yeah. So this is a Lambda cron job that runs. It used to be a cron job that ran on AWS in an instance. Now it runs in Lambda, and it is much faster and smoother. And it runs every 5 minutes or so to move the data out. And that way we ensure that the Redis instance doesn't grow too large because Redis doesn't store huge amounts of data all that well. And then it enables the lookups to happen faultlessly in either Redis or S3 when the data comes through back to the ETL. So once it's out of Redis, we have all this data in memory. And we want to store that in S3 in an efficient way. So we have a lot of data for events in one big minute chunk. And similar to Redis, we don't want to store that all in one place. Because what would happen is if you had one giant S3 file, which is efficient to write, when you're doing the lookups, you don't want to look up a gigabyte file and try and pull one event out of there. So what happens is we split those data points into many S3 files and write them out with a ID for the event as part of the file name, and that is the maximum ID in that file. And so what happens is we sort those by ID, and then we write the maximum ID out to each file. So when you're looking up by ID, all you have to do is look for which file has an ID bigger than yours, but not the maximum one that's bigger than yours.
Okay. So in that way, you've kind of built yourself an index, really.
Sure. Yeah. And as part of that, here we also have some chunk smoothing, so to enable that the chunks become the same size. So if you have like 50 files that you're writing, you don't want to write 49 huge files in one small file. So this part here, with the chunk size being variable, enables it to calculate what chunk size would be best for smoothing out those files. And then another part of this, as you mentioned, it's a Lambda function, is if something fails or takes too long and gets cut off, what happens is this is resilient to failures, so that if something writes to S3 twice for the same minute timestamp, what can happen is this file name right here actually has the start timestamp of the cron job in it, so that if the cron runs later, it knows to look in the first cron run first, and then if it can't find it there, it'll look in another run for the S3 write.
Right. So in that way, you've not got the risk of object name conflict.
Right. Yep. And yeah. So it helps if you so you can run the cron more than once on the same data. It's very resilient to failures that way. So you don't remove the data from Redis until you're sure it's an S3, and then you can have your lookups still be very fast.
Great. And I guess off the page somewhere we've got an S3 put object command.
Yeah, so down here we put the data into S3 and then we remove it from Redis. And it also, so also part of this that we figured out is writing the objects to S3 was pretty efficient and reading them. But one part of that is you need to list the files in S3 in order to get your file names out. The S3 list took as almost as long as the S3 get, but in order to work around that, we actually store the S3 file names in Redis under a different key. So that way, when you look up an event, you just pull the file names out of Redis, and then you can go. The only S3 operation you need to do is one get, which is both cost and much more time efficient.
Okay, great. Thanks, Jason, for sharing.
Thank you.
Okay, and thanks for watching. This is my code.